Continuing on with our 10.3 lesson, we have some more examples to go through of how to solve logarithmic expressions, or say logarithmic equations. So in this case it says if all the terms have logs, then reduce each side to a single log, and we can just drop the logs out. And again, if that sounds a little confusing, I'll show you what we mean here. Notice how in this case all of them have a log base 4. So as long as we can get log base 4 of something equals log base 4 of something, we can just get rid of the logs, because it would be like taking both sides 4 to that power. So we would say then we can simplify this to log base 4 of 3x plus 2 equals, we have log base 4 of 5 plus log base 4 of 4, and that's the addition in between them. So we can use that multiplication property. Log base 4 of 5 times 3 is going to be 15. Now, remember that if we have log base 4 of something equals log base 4 of something, we can essentially get rid of the log base 4s, in which case then we just have 3x plus 2 equals 15. So bring that down, give us a little more room to work with. 3x plus 2 equals 15. Now all we have to do is solve for x, so subtracting 2 from both sides leaves us with 3x equals 13. Divide both sides by 3, and we get x equals 13 thirds. Again, you always want to check that, and I'll just give you a hint, this one checks out. So if we have, again, 4 log base 2 of x minus log base 2 of 5 equals log base 2 of 125. This one might take a couple steps to simplify. Remember that anytime we have a logarithm with a number out in front, that's the same as taking it, the log of that base to the number to that power. So we would say this is log base 2 of x to the 4th minus log base 2 of 5 equals log base 2 of 125. Now, at this point, we still have 3 things. So it's not 1 on one side and 1 on the other. So we can't simplify everything quite yet. So we would have to bring it down a little more and say log base 2 of x to the 4th over 5, because we have this subtraction in there. And that property says that we can bring it into one piece and call it log base 2 of x to the 4th divided by 5. And the right side stays as log base 2 of 125. Now at this point, we just get rid of those log base 2's. And we now have x to the 4th over 5 equals 125. Now we just solve for x like we normally do. Multiply both sides by 5, and we get x to the 4th equals 625. We'd have to take the 4th root of both sides then. So x equals 4th root of 625. And remember, that technically means it's going to be plus or minus 5. You can't just say one or the other. It would be plus or minus 5. But if we come back to our original equation, we can't have this x here being a negative 5. Can't be any negative number. So in the end, we know for sure, not this negative, we would just have x equals positive 5. And that is our answer. Now we're going to look at using known logs or known values to approximate others. So in this case, if we know that log base 5 of 2 is approximately 0.4307, how can we approximate the value of log base 5 of 250? Now another thing that doesn't necessarily give you here, but we can think of intuitively, if we have log base 5 of 5, what is that saying? Well, that's saying that 5 to some number x equals 5. So what is that number x? Well, x has to equal 1, because 5 to the first power equals 5. So that means that log base 5 of 5 equals 1. So we know 2 bits of information. Another thing that we can find out is 250. Let's break it down into some factors of 5 and 2. Well, it'd be 5 times 50. 5 is already a 5, so we're good to go. 50 is 5 and 10, so there's one of our 5s. 10 is 5 and 2, so now we have all of our 2's and our 5's. So we would say that 250 is the same as saying 5 to the third power times 2. So if we need to find log base 5 of 250, that's the same as saying log base 5 of 250 is 5 to the third power times 2. Now we're chugging right along with our simplification process. We've changed log base 5 of 250 into log base 5 of 5 to the third power times 2. Now we can use our properties in reverse and say that if we have log base 5 of one number times another, we can call it log base 5 of 5 to the third power plus log base 5 of 2. And we're getting a little bit closer to our desired destination. Log base 5 of 5 to the third power. Remember, we can bring that 3 out front here and say 3 times log base 5 of 5 plus log base 5 of 2. Now we have all the values that we know, because log base 5 of 5 is 1. Log base 5 of 2 we know is 0.4307. So we have 3 times 1, which is 3, plus 0.4307. So we'd say in the end that it equals 3.4307. So that is our approximation value. All right, let's try that again. If we know, if we're given that the log base 6 of 8 is approximately 1.1606 and log base 6 of 32 is approximately 1.9343, and we need to approximate the value of log base 6 of 4. Well, we know that 4 is the same as saying 32 divided by 8. So, naturally, the log base 6 of 4 would be the same as saying the log base 6 of 32 divided by 8. And we know that log base 6 of 32 over 8 is the same as saying log base 6 of 32 minus log base 6 of 8. So we've broken it down even further. Now at this point we know that log base 6 of 32 is actually 1.9343, and the log base 6 of 8 is actually 1.1606. So we just have 1.9343 minus 1.1606. So in the end, our value equals 0.7737. And that would be our approximation value. And we've got another one here. We're looking at using what we know, the log base 5 of 6 is approximately 1.1133 to approximate the value of log base 5 of 216. Well, again, we don't necessarily need to go all the way down into our prime factorization, but we can break 216 into 6's. So 216 would be 6 times 36, and 36 is 6 times 6. Or we can just say that 216 equals 6 to the third power. So we can say log base 5 of 6 to the third power is the same as log base 5 of 216. So once we're here, we would then say that this is the same as saying move that 3 out to the front, 3 times log base 5 of 6. And we know that log base 5 of 6 is actually 1.1133. So we have 3 times 1.1133. So in the end, we would say that equals 3.3399. And that would be our approximation value for this case. So make sure we're asking any questions we have about logarithms and properties of logs. Otherwise, stay golden.